In geometry section 4.4, we're dealing with triangles that are equal to each other. So you remember in the last section, we had two triangles that are equal to each other. And what that means is all their angles are equal to corresponding angles. So this would be equal to this, this would be equal to this, this would be equal to this. But not only that, but their sides. So this would be equal to this would be equal to this, and this would be equal to this. This makes these triangles equal. Now, in section 4.4 and section 4.5, we're going to be dealing with shortcuts. So instead of you trying to figure out all three sides and all three angles, making 6 things that you have to pay attention to equal to each other, there's 4 shortcuts that are being shown to you. The first one is very simple. It's called side, side, side. So what that means is, as long as you can prove that the 3 sides are equal to each other, okay, without even dealing with any of the angles, then you can say that the triangles are equal to each other. Okay. The next one is side, angle, side. So if you can prove that 2 sides and 1 angle, okay, is equal to each other, then this would be called. Then without proving anything else, you can state that they're equal to each other. So our 2 shortcuts again are side, 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 and side, angle, side. Okay? You can abbreviate it as SSS, SAS. Don't forget to pause and write down and do the vocabulary. Okay, so the next one, so what we're going to go into examples here, and it's asking us to write a proof. And it's saying that it's giving us the given. So first, if you remember proofs, I know you hate them, but if you remember proofs, the very first thing that we always start with is, again, the given. So the first given says that RQ is parallel to TS. Okay? So that tells me that RQ, this, is parallel to TS. It also tells me that RQ equals TS. So, our 2 shortcuts, again, are either side, 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 or side, angle, side. And what it's asking us to do is to prove that these triangles are congruent. So in order for us to do that, we could take the long way and try to prove all 3 angles are equal to each other and all 3 sides, or we can choose one of the shortcuts. And it cuts our work down to half. So we already have here, it tells us that RQ is equal to TS. So already, is this a side or an angle? This is in fact a side. So each of these has a side taken. So far we have a side. Now we have to see if we can find more sides or more angles to each other. And this is telling us that it's parallel. So if I'm going to take RQ, here's RQ, and, TS. So it tells us right here that these lines are parallel, and there's this huge line right here. Now, if it tells you that this is parallel to this, then we can go back to the section with, remember, the transversals. Because these are equal, we know that this angle, RQS, is equal to this angle, TSQ. Because of what? This is called, remember, it's alternate interior angle. So we know here that angle RQS equals angle TSQ because of alternate interior angles. Now, you might say, well, how do I know to use that? Well, if they give you parallel lines, they want you to use those. They want you to use those reasonings, and that's why it's very important for you to have kept your flipper. So this is alternate interior. So this is telling me that this and this is equal to each other. So that's telling me here that this is a what? This is an angle. So I know that I can no longer use this. Okay? That now I need to find another side. But the thing with this triangle is that they both share a common side, which is QS. Do you see that? So angle QRT, this is not right, QRS and STQ. Sorry. So angle QRS is equal to angle STQ. They're not equal, but you see this line right here. That says that angle QS equals, side QS equals side QS. Okay, this is called reflexive. Remember, a line equals itself. This is then called a side. Okay? So because I have this shortcut, it's telling me that now these triangles, triangle QRS equals triangle STQ. Because, and this is my reasoning, either this one or this one had to be a reasoning, but I did SAS right here. Sometimes it's not necessarily given to you in this order. Sometimes they'll give you it in different orders. It just so happens to work out that way. But the whole goal is try to prove these triangles equal. Now I can either prove it equal by proving all the sides are equal to each other and all the angles, which that means I have a lot more on the list, or I can choose one of the shortcuts they've given me. Either I can prove all the sides are congruent, or I can prove that two sides and an included angle are congruent. So go ahead and try page 229, number 4, and I will see you in class.